In this segment, we turn our attention to proofs of a different sort, called structured proofs. Structured proofs are similar to linear proofs in that they consist of sequences of reasoning steps. However, they differ from linear proofs in that there's more structure. In particular, in structured proofs, groups of sentences can be grouped together into subproofs nested within outer superproofs. Here's an example. It resembles a linear proof, except that we have grouped the sentences on lines 3 through 5 into a subproof within our overall proof. The main benefit of structured proofs is that they allow us to prove things that cannot be proved using only ordinary rules of inference. In structured proofs, we can make assumptions within subproofs. We can prove conclusions from those assumptions, and from those derivations we can derive implications outside of those subproofs, with our assumptions as antecedents and our conclusions as consequents. Structured proof shown here illustrates this. On line 3, we begin a subproof with the assumption that P is true. Note that P is not a premise of the overall problem. In a subproof, we can make whatever assumptions that we like without contaminating the outer proof. From P, we derive Q using the premise on line 1, and from that Q, we prove R using the premise on line 2. And that terminates the subproof. Finally, from the subproof, we derive P implies R in the outer proof. Given P, we can prove R, and so we know P implies R. The rule used in this case is called implication introduction, or II for short. As this example illustrates, there are 3 basic operations involved in creating structured proofs. 1, making assumptions. 2, using ordinary rules of inference to derive conclusions. And 3, using structured rules of inference to derive conclusions outside of subproofs. Let's look at each one of these operations in turn. In a structured proof, it's permissible to make an arbitrary assumption in any nested proof. The assumptions need not be members of the initial premise set. Note that such assumptions cannot be used directly outside of the subproof, only as conditions in derived implications, so they do not contaminate the superproof or any unrelated subproofs. For example, in the proof we just saw, we used this assumption operation in the nested subproof even though P was not among the given premises. An ordinary rule of inference applies to a particular subproof of a structured proof if and only if there's an instance of the rule in which all of the premises occur earlier in the subproof or in some superproof of that subproof. Importantly, however, it's not permissible to use sentences in subproofs of that subproof or in other subproofs of its superproofs, only in the subproof itself and the superproofs of that subproof. For example, in the structured proof we've been looking at so far, it's okay to apply implication elimination to 1 and 3. And it's okay to use implication elimination on lines 2 and 4. However, it's not acceptable to use a sentence from a nested subproof in applying an ordinary rule of inference to an outer proof, as illustrated here. This sort of reasoning can be formalized with a new type of rule of inference. Like an ordinary rule of inference, a structured rule of inference is a pattern of reasoning consisting of some premises and 1 or more conclusions. As before, the premises and conclusions can be schemas. However, the premises can also include conditions of the form phi proves psi, as in the example shown here. The rule in this case is called implication introduction because it allows us to introduce new implications. A structured rule applies to a particular subproof of a structured proof if and only if there's an instance of that rule that satisfies the following conditions. A premise of the form phi proves psi is satisfied if and only if there's an earlier subproof within the current proof where phi is the only premise and psi is any conclusion. In other words, if the earlier subproof proves that psi follows from phi. Once again, looking at our example, we see that there is an instance of implication introduction, which I've written here over on the left, in deriving line 6 from the subproof on lines 3 through 5. This exercise tests your grasp of structured proofs by asking you to prove a result using implication introduction.